As a meteorologist, I'm always studying the sky, but today I'll be in the sky with Texas Southern University Flight School. Costa shows me the airways and we discuss how the weather impacts aviation. The thermodynamics behind how a plane gets up into the sky, it's a mystery to a lot of people, but there's actually some science behind it, and the science behind it correlates very well to the weather and our day-to-day weather. We have highs and low pressure that form around the plane. Go ahead and explain how that helps get the plane up.
In very, I guess, very simple terms, we have a principle known as the Bernoulli principle. And basically what that is telling us is that as molecules move faster, their pressure, the pressure of that air mass, will decrease. So we have air moving over the top of the wing, which you can see is a very curved surface, all right? And there's air moving underneath the wing. The air moving underneath the wing will have a higher pressure than the air moving atop the wing. That discrepancy between low and highs is really what pulls the airplane up. So we think of lift as a force that brings the airplane up, not by pushing it, but by sort of drawing it up into the air based on this Bernoulli principle.
And that plane you saw there, guess who's inside?
We want to stay at very minimum 10 miles away from any thunderstorm cell. So these cells, they're made up of these rising and falling columns of air. And those columns of air are moving very, very quickly. As the flow comes down, it can spread, causing all sorts of really, really bad stuff.
For example, a microburst, capable of strong winds with little to no warning. Therefore, it is always important to pay attention to the day's forecast before takeoff.
As the temperature increases, so does the density altitude, and planes just don't perform as well at higher altitudes. So when we're rolling down the runway and it's 50 degrees outside, well, the airplane's really, it knows where it is, right? It's got a lot of density producing all that lift. It's great. As we get into our Houston temperatures in the 90s and so forth, all of a sudden the airplane thinks it's rolling down, and yet it's at 3,000 feet. So it's gonna perform a little bit worse.
And before takeoff, you don't want things to be too cold either.
Then we start having concerns regarding icing, forming on the wings, forming on parts of the aircraft, the fuselage, and so forth. So those are things we try to mitigate with various forms of technology, be that chemical technology or be that electrical. We try to find solutions to those problems so we can always be in the air.
Speaking of solutions, what is in the de-icing solution that makes it so potent to getting the ice off the plane or preventing the ice from forming onto the plane?
Well, you're asking now a chemical question, which is outside of my expertise. What I can tell you is basically what it does. It changes the freezing temperature.
So very similar to why we apply salt to the roads, because the salt will lower the freezing point. Next, we cruise the sky and talk about the weather's role in getting back down to Earth.